In our module on the recording industry, we learned how LPs and 45s developed as new record formats and took over the recorded music market starting in the late 1940s. Now, about the same time, another sound recording technology originally envisioned back in the 19th century and that will eventually permanently change the music production methodology is beginning to make its mark in the industry: magnetic recording. Magnetic recording was first proposed by an American engineer, Oberlin Smith, in 1878 after his visit to Edison's laboratories in Menlo Park, New Jersey, where he got a chance to see firsthand Edison's work on his phonograph. 10 years later, in 1888, an electrical engineering publication, Electrical World, published Smith's article describing his own new sound recording and reproduction method. His main motivation for developing a new way to record sound was his disappointment with the sound quality of the Edison's phonograph, which was marred with scratching noises of the needle riding along the cylinder's groove. Smith figured that if the mechanical nature of Edison's recording and reproduction mechanism could be somehow avoided, the noise would disappear. So he started thinking about electricity and electrically induced magnetism as a possibility and devised a machine that could theoretically record and play back sound using magnetic field. As a sound recording medium, Smith describes a cotton or silk thread into which steel dust or thin pieces of steel wire are embedded throughout. Such thread would be susceptible to magnetism all along its length. He hypothesized about a solid thin wire as a medium as well, but thought that perhaps such medium couldn't retain required various degrees of magnetism, so he stayed with the metal particles embedded thread. The thread was to be wound on the supply and take-up reels, driven by a clockwork mechanism. Between the reels would be placed a coil of wire through which the thread would be moving. The coil would be connected to the telephone mouthpiece, which, as developed by Alexander Graham Bell by this time, was made to create a small electrical current, the intensity of which corresponds to the vibrations of its sound-sensitive diaphragm that was vibrating as it was spoken into. That varying electrical current would create magnetic force of the corresponding strength in the coil, which would in turn magnetize the thread as it was moving through it with various magnetic patterns, again corresponding to the vibrations of the diaphragm. The sound is thus captured onto the thread as various degrees of magnetism along its length. Now, to hear the captured sound back, the process is reversed. The now magnetized thread is rewound and made to move through the wire coil again. But this time, the thread's magnetic patterns induce a magnetic field of various strengths onto the coil, which in turn produces small electrical current corresponding to the variations in induced magnetism. That electrical current flows back to the telephone mouthpiece, which now becomes a speaker, producing sound as its diaphragm vibrates according to the electrical current it receives from the coil. And there you have it, the first magnetic recording and reproduction design in history, devised by the ingenuity of Oberlin Smith back in 1878, as published by Electrical World in 1888. Unfortunately, although he filed the pre-patent paperwork for his invention, Smith failed to follow through, and the patent for the magnetic sound recording device using wire as a medium, named telegraphone, was granted to Danish engineer Valdemar Poulsen in 1898 by Denmark and in 1906 by the United States. Now, there is no question that Poulsen made and publicly demonstrated the first operational and commercially viable version of the magnetic recorder. But it is just as unquestionable that Oberlin Smith invented such device 20 years earlier, and that what Poulsen built was the exact same design, with the exception of using a solid thin wire as a medium instead of a metal particle embedded thread. Smith was a victim here of his own business success in another field though. His metal press factory in New Jersey was building presses for the likes of Ford, Eastman, Kodak, Chrysler, US Mint, and Cadillac, and he simply didn't have enough time and energy to devote to something as esoteric and as commercially questionable as magnetic sound recording. He did try to rectify the situation when he learned of the Poulsen's patent, but to no avail. And so if you look up the magnetic recording invention today, you will find Poulsen's name next to the first patent in the field. But be aware of the indelible contribution that Oberlin Smith made to this technology, which eventually not only changed the music industry, but also led to video and digital data storage mediums, which changed the whole world. Poulsen's wire recorders, manufactured in the United States by the American Telegraphone Company, never became a commercial success, in spite of all the efforts to make them a part of homes and businesses across the country. They were mostly marketed as telephone answering machines and dictation devices, but the orders never reached a critical mass, and the American Telegraphone filed for bankruptcy in 1914, though their telegraphones continued to be manufactured in small numbers throughout the early 1920s. Poulsen's European patent expired in 1918, and it became free for all to use and develop further. A German inventor, Kurt Steele, modified the telegraphone in the early 1920s by adding electronic amplification to it and by housing a recording wire in a portable, removable cartridge, which makes it the first relative of a cassette tape, actually. He called his device a dailygraph and produced it and distributed it at this time through the company owned by one of his licensees, Carl Bauer, a company called Echophone. In the early 1930s, British film studio owner Louis Blattner acquires the rights to manufacture it in England, modifies it to use a metal tape instead of a wire, and calls it Blattner phone. The British broadcasting company BBC, right, buys one and starts broadcasts using pre-recorded material recorded on it. Blattner soon goes out of business though, and the British Marconi Wireless Telegraph Company buys the rights to the device, and the BBC acquires their modified version called the Marconi Still Tape Recorder. It had an improved mechanism, thinner and less wide wire tape than the Blattner phone, which was much easier to handle because of the reduced weight of the reels, and represented considerable savings on the tape material itself. Meanwhile, Echophone was sold to a German telephone equipment manufacturer, ITT, who continues its production in somewhat modified form through its subsidiary firm called C. Lawrence and calls it Textophone. In a few years, C. Lawrence modifies the Textophone and starts using a metal tape for recording like Blattner phone and renames it a Staltonband machine, which translates to steel tape machine or steel audio tape machine. Thousands were sold to German Nazi government for various uses, including recording of their spying on the telephone conversations and the radio wave communications throughout the country. While that development from the Steele's dailygraph to the Marconi Still tape recorder and the Staltonband machine was unfolding, all of which proved to be a dead end technologically, by the way, another patent in Germany starts the chain of events that would bring us directly to tape recorders as we know them today. In 1928, Dr. Fritz Flumer received a patent for coating a paper tape with iron oxide powder using lacquer glue, thus eliminating all the bulk and weight of a wire and a metal tape as a magnetic recording medium. 4 years later, in 1932, a German electronics company, AEG, partnered with Flumer in their effort to develop a brand new magnetic tape recorder they called magnetophone, based on the Flumer's tape design. That same year, AEG also partners with a German chemical conglomerate, IG Farben, to create and manufacture a tape for the recorder. IG Farben entrusts the task to its two divisions, a fine iron powders manufacturer called BASF or BASF, and the photographic film manufacturer called AGFA, AGFA. After experimenting with a number of different tape types for a few years, a acetate plastic tape coated with iron oxide particles became the standard tape in a magnetophone. It was easy to cut and edit, tough to break and tear, durable, and evenly coated with metal particles of, at the time, optimum size and shape. The magnetic recording heads, the electronic circuitry, and the mechanisms were greatly improved as well. Self-contained and portable K1 model of this new magnetic recorder was presented for the first time at the Berlin Radio Fair in 1935, and it was an instant hit with the German broadcasters. The following year, in 1936, Sir Thomas Beecham and the London Philharmonic Orchestra were invited to Germany for a historic concert and recording. As a result, on November 19th that year, the orchestra performed at the BASF's concert hall near its plant in Ludwigshafen. The concert was recorded using the new AEG's magnetophone recording machine and the single condenser type microphone made by a German company, Neumann, that will eventually become the synonym for the highest in the microphone quality, as it still is to this very day. This historic concert is the first high-profile recording and the first orchestra recording using the magnetic tape recording technology. The orchestra played Mozart's 39th Symphony in E-flat major.